Now we're going to dig into the HTTP request and response quite a bit more in depth, and we'll start with the requests. So we're going to go through the start line requirements, those different fields. We'll go through some of the different request headers that can be included, and then we'll actually look at a packet and go through some of that in depth with the packet instead of just discussing it as well. So we'll do all that here. Now, starting with the request, this is actually going to be coming from something on an endpoint device. So generally we think of that being like a browser. It doesn't have to be a browser. It doesn't have to be something like Chrome or Firefox. It can actually be something scripted, maybe like a Python script that has using URL lib to go out and get something. It can really be really pretty much anything. Anything that is capable of generating an HTTP request and acting as an HTTP client can be an HTTP client. That's a bit recursive when you say it that way, but you kind of get the point here. Now, the start line is the first part of the request. It's the required portion, and it has 3 fields. The first of those is method, and that's probably the most important field in the HTTP request because it defines the nature of the request, what type of request it is. So we have things like HTTP GET, which means to retrieve a resource from a server. We have POST, which means to transmit data to the server. So we have different types of methods that define the nature of the request. Here in a minute, we'll go to a dedicated slide where I discuss some of the most common methods, and we'll actually go through some stimulus and response examples related to that as well. Next, we have the URI, which identifies the location and resource which is being requested or interacted with. So if it's a GET request, we're actually downloading that resource. If it's a POST, for instance, we may be submitting data to that resource or to that page. So this can be, normally we think of this as maybe an HTML page or a PHP page, JavaScript, what have you, any type of specific file that exists on a server that we're going to be interacting with. So this can be just the file name if it's in the root directory, or it can be a path. So /public /folder1 /folder2 /index.html. So that's the URI, is that portion of the request. Now take note here, we're not necessarily talking about the DNS names. We're not talking about chrissanders.org. We're talking about /index.html, the latter half of that. We'll see the chrissanders.org part later in a different portion of the request. After URI, we have HTTP version. For most of what you see, you're going to see HTTP 1.1, but it's a simple version string that shows the fields. Now, remember here, these are terminated by a carriage return and a line feed, /r/n. And a couple examples of this. Here's one where our method is GET, our URI is /home/store.html, and our HTTP version is HTTP 1.1. Notice again how each one of these is separated by a space. That's what separates each of the particular entries in the HTTP request start line. One more example. Here's an HTTP post. We're posting to the URI /wp-comments-post.php. And again, we're using HTTP /1.1. So the request line is pretty straightforward. Really, most of the time you're analyzing HTTP data. A lot of times the request line is sometimes the only thing you're going to look at. I won't say most of the time, but a lot of the time that's going to be the only thing you look at is the request line, unless you need to dig into the specific headers a little bit more in depth. But nonetheless, this is the HTTP request start line, and these fields are all required with every HTTP request that you'll see. So I mentioned that a required component of the start line is the request method. So I do want to quickly go through a couple of those now. I'm just going to give you a quick description. We'll go through some examples later on of stimulus and response, and I'll actually show those in practice where it might be a little more clear. But just to summarize them, I do want to have a description that you can go back and reference if you need to. Now, the first one is the most common, and that's a GET request, which simply means to retrieve data from a server. When you browse to a website and you get a file from it, you're using a GET request. That makes sense, right? So GET is to retrieve data from a server. The next most common thing you'll see is a POST, and that simply means to send data to a server. Now, it's not the only way to send data to a server. We'll talk about puts here in a minute, but generally, most of the time you're submitting data to a server, maybe via a form, or you're inputting a username or a password or something like that. You're using a POST request many times to submit that particular data. Next up is a head request, and a head request is almost identical to a GET request, but instead of actually getting data or getting information, you're only requesting the headers, in this case, the response headers of the server. So you're retrieving that header information with no HTTP message body. So head is just getting those headers. There's some legitimate uses for that, also some illegitimate ones as well. People will do a head request to just gather information about a server. Not too common, but you see that occasionally. Not much point in it when you can also just use a GET request, and head requests look a little bit anomalous sometimes because they're not super common, but head is a valid HTTP request method. Another method is put, and put is similar to a post, and then it's also used to send data to a server. But whereas a post can append data or change data, put, generally speaking, completely replaces data. You don't see put used nearly as often, but there are cases where that makes sense. The definition between post and put is a little bit convoluted. You can read into that a little bit more if you want to. But I understand they're both ways, nuanced ways to send data to a server, with post being generally the most common. Finally, we have connect. Connect is used for tunneling through proxies. So we have this concept of a web proxy, which is a device or a piece of software sitting on your network, and all of the devices within your network tunnel their HTTP communication through that proxy. So you only have one single point of access that's going out to the internet on your network. A lot of good reasons you use a proxy, not the least of which is centralized logging of requests and responses for security purposes. You can also do some inline content filtering, blocking dirty websites, blocking gambling websites, whatever you want to block there, and also blocking potential malware sites as well. So a lot of reasons you would use a proxy, and connect is often used in relation to a proxy server. So these are really the 5 most common request methods. There are a few others. You can go look at those in the HTTP RFC if you would like to. We're going to focus mostly on GET and POST here because those are by far the most common you'll see. But these are the different most common request methods that you might encounter on a day-to-day basis. Now let's talk a little bit about the request headers that follow the start line in an HTTP request. There are a whole lot of these. They can be defined pretty broadly based upon whatever client you're using. And there are many more than we're going to talk about today, but I'm going to talk about some of the most common and most universal that you're going to see across the HTTP data that you're going to analyze, and the ones that I think are quite important in the nature of the HTTP transaction. We're going to start with the host. And I mentioned earlier we have a URI that's in the start line, and that's what we're requesting, right? We're requesting, /home/folder1/folder2/index.html. That's the thing we're requesting. But the host field is important because it specifies the individual host the request is made from. So this is actually, in many cases, your domain. So it can be chrissanders.org, but it can also be your IP address. And you also have the option here of specifying an optional port as well. Maybe the server is listening on multiple ports. Now, generally, HTTP is listening on port 80, although that can be a few other things. Often people will use 8000 or 8080 or really anything, but port 80 is the standard for that communication. So the host specifies that individual host field. This is a required field. It's in this request header section, but it is required, I believe, with HTTP 1.1 at least. So you'll see that pretty often. So generally speaking, if you want to reconstruct an HTTP request, you can take the host field plus the URI field, combine those together, you get the full URL, and you can just copy and paste that into a browser to recreate that specific request. But you do need both of those things in this particular case, or the IP address plus the URI perhaps in some cases as well. A couple examples of that, I mentioned chrissanders.org would be the domain. You can do an IP address as well. It's not uncommon for clients to browse to websites via IP address. It's definitely much rarer. It's not something that you'll see often in many networks. Some people build intrusion detection signatures to look for this because it's uncommon enough in their network that they want to know about it. But it's perfectly valid per RFC spec and is okay within the context of an HTTP request. The next thing I want to talk about is refer. And you might be saying to yourself, well, hey, Chris, you idiot, you misspelled refer. And actually, I didn't. The folks who wrote the RFC did. Refer is actually misspelled in the HTTP header per the spec. So that's quite unfortunate, and it's probably caused a lot of people who learned protocol analysis early on to misspell refer in other walks of life. But nonetheless, refer is misspelled wrong here on the slide intentionally because that's how you'll see it in the packet. Now, the refer is pretty straightforward, and it specifies where the request URL was obtained from, really mostly for the benefit of the server. So if I'm going to chrissanders.org/ page 2, how did I get there? I could have very easily typed that just directly into my address bar, right? In that case, there won't be a refer. But if I was on chrissanders.org/page1.html and click the link to go to page2.html, then the refer will be chrissanders.org/page1.html. It's wherever I got that link from and clicked that link from, it's that referred me to that particular page. So that's the refer. And again, this is done really for the benefit of the server, and specifically for one is troubleshooting reasons. So if people are getting to a specific, maybe an error page, I want to see how they're getting to there, how they're getting referred to that page. Another is for search engine optimization, things like that, tracking behavior of users and so on. So I have a particular, let's say a product purchase page, and I want to know how people are getting to it. I can actually track the refer that referred them to that particular page. So that's for the benefit of the server and the server administrator to analyze and review that data. Not necessarily super important in the context of making sure the HTTP request is successful. Next and last on this slide is the user agent string. And user agent is quite important because it identifies the application that made the request. Now, when I say application, I'm talking about HTTP client. And again, HTTP client can be a number of things. Generally, we think of it as a browser. So Google Chrome, Microsoft Internet Explorer, Mozilla Firefox, those are all HTTP clients, and they're all represented via specific user agents. Not just one user agent, oftentimes multiple, because they're represented with different versions of user agents. So even Google Chrome, which is one browser, has hundreds or thousands of different user agents associated with it, but they're all used to identify Google Chrome operating at a specific version number on a specific platform. Here's an example of a Google Chrome user agent. It's a lot more complicated than just saying Chrome. There's a lot of stuff here, a lot of things about what architectures it's compatible with, what operating systems it's running on, and so on. So these can be dissected in different ways. We'll talk about that as we get along later. But this is just a single user agent identifying Google Chrome. Now, keep in mind, remember, an HTTP client is really anything that is capable of making an HTTP request. It doesn't have to be a browser. You can actually write a Python script using URLlib, which will actually go out and retrieve an HTTP resource. So in this case, your user agent could identify that particular Python library, which would be identified as this. So python-urllib, and it looks like this was version 3.1. So user agents are widely variable. There's a lot of them out there. You can use these on the server side if you're a server admin, for instance, to track, what distribution of browsers are visiting your website, or what distribution of underlying operating systems are visiting your website, because that information is related to some degree with this as well. So that's pretty helpful from a server side. Now, the important thing to keep in mind here, user agents can be anything the client wants them to be. They don't have to conform to really any particular standard. They don't have to, just because I'm using Chrome doesn't mean I have to send packets with a user agent that says it's Chrome. I can spoof that. If I'm writing a script and that script is using Python's URLlib to communicate with the web server, I can actually change what that user agent is. I can make it say anything. I can actually even make it say it's the one above. I can make it say it's Google Chrome, even when it's not. I can lie about it, right? So user agents are incredibly fallible in that regard, and that makes quite a bit of a security issue when using them. A lot of people are making malware will disguise things as specific browsers. A lot of people writing malware will actually write custom user agent strings to help identify their malware when it does its command and control check-ins. So user agent is very important in that regard. We can use it to spot anomalies, things that don't quite fit. If we have a system that we know does not have Chrome installed and we see it's requesting things from an HTTP server via Chrome, then we know maybe it's malware, it's something else impersonating it. So user agent's very important in that regard. Spend a lot of time on the security side of the house thinking about and analyzing and looking at user agent strings, looking for anomalies. The next couple of headers I want to talk about relate to the content of the request that's being sent and the data that's anticipated to come back. First, we have the concept of accept headers or accept request headers, and this really encompasses quite a few different things. I've highlighted a few of those here. We have accept encoding, accept character set, accept language, a few different things, and they basically describe what is acceptable from the server in regards to a response. So think of it this way. I have a client, and I can only speak so many languages and interpret data in certain ways. I'm sending a request to a server, but at this point, I've not negotiated any communication parameters with it yet, right? Everything that the server knows about me is going to come in this initial GET request. So if I'm asking for information, it makes sense to tell that server, hey, I need that information back in this specific way if it's going to be useful to me. Now, the hope is the server can respond to that. It can't always do that, but most cases in general communications will see that it does. So we have a couple different categories of ways we can do that. Encoding, character set, language, those are all fairly self-explanatory things, and those are ways we can define what data we'll accept. So a couple examples. One is accept language. If we're using an English system with an English browser, we want to accept data in English of some sort, right? So we specify those languages here. We have EN-US for US English, just EN for normal English. And we also have this concept, this header supports something called a quality setting, which relates to how close something is to English. We won't get into that too much, but that's what's that Q equals 0.5 there under accept language. Accept encoding is another example. So in this case, oftentimes HTTP communication will occur using gzip encoding because that's just a more efficient way to transfer data across the wire, and if things can be unzipped on the other end, that's pretty darn efficient, decreases the size of data being transmitted. So here, a browser that says accept encoding in gzip is accepted, will allow the server to send its response back gzipped instead of just in plain raw fully inflated text. So that's an example of accept encoding. Now, we also have the content side. So accept is talking about the concept that's coming back in the response. These content headers are about the content being sent in the request. And remember, we don't always have content from the example earlier. Sometimes we're making a request and there's no specific content, but many times we're making something like a post. So we're sending data to the web server. Again, maybe filling out a form, a username and password, something like that. So when we have that content, we can specify things about that content so that the server better understands how to parse that data. And a lot of the same things you'll see are present for content that are present for accept. So we have things like encoding and language. If I'm sending you data that's gzip encoded, I got to tell you that, right? So you know how to interpret it. So the browser doesn't, or the server just doesn't try to render gzip data when it needs to be decoded first. So you see content here. We'll actually see content again on the other side because data can go both ways. So we'll see that on the response side as well. But for here, we also have it on the request side, and we can specify things like encoding type, language, or length. So for example, we can specify content type. In this case, it's a MIME type, which is application encoded URL form data. So someone submitted a form and a post request. We can also specify the content length, so the amount of data being transmitted, so the system knows how to process it, when to stop processing that data in the HTTP message body. In this case, it's 179 bytes. So a few different options here in regard to how we do that content. So these are just a couple different HTTP request headers that you're probably going to see more often than not. You see accept quite a bit. You don't see content as much unless we're looking at a post. So we'll see a few of these as we go through additional examples. I flip back over now to some HTTP traffic so I can actually show you some of these, the format of the request that's being made. Now we've looked at one of these already, so you kind of get a sense of how the line-based protocol system works. But let's go ahead and look at one of these requests. Now in this case, I've gone ahead and filtered this capture file, and I said HTTP request method equals get. So I want all the get requests. Remember, that's a specific method. Now I'll go here and I've just picked one of these at random with a pretty short URI here. We can see the start line is in the info column, but let's go ahead and dig into it down here in the packet details. Now I've expanded this and we see that the start line is right off the bat the first thing we see. We see that the request method is get, which means we're retrieving data from the server. And we have a request URI that is /icons/in.gif. So in this case, we're actually retrieving a GIF image. So we're not retrieving an HTML document. It's actually a GIF image file. And we're using request version 1.1. These HTTP 1.1. These are the required fields of this as a part of the start line, and they're all grouped nicely here together. So everything after this, up until the point where we get to the message body, if there were one, is going to be your additional headers. The very first thing we see is our host header. Remember, we can now take this host information, add it to the URI information in the start line, and that's how you could basically reconstruct this GET request and re-execute it. So we could take a.espncdn.com/icon/in.gif, and assuming that file's still there, we could put that into a browser and retrieve that file directly outside and recreate that part of the stream here. So that's the host information. Again, this can be an IP address. Here it's a domain name with a subdomain, so we have that available. Next, we have the user agent string, which represents our client technology. In this case, it's identifying itself as Mozilla Firefox. We see Mozilla 5.0, we see Firefox 3.5.8 over here, and it looks like we're running on Ubuntu, at least in this particular example, Ubuntu Linux. So it tells us a little bit about both the browser in this case and the underlying architecture that it's installed on. After that, we have a few different accept headers. Now remember, accept is to tell the server what types of content we can accept or expect to get back. Now, since we're requesting an image file here, it's no surprise that we see that we're accepting different MIME types related to images. So we see image/PNG, image/star, which is going to get a lot of different image types available. So we can pull back anything that is of that particular MIME type. We also have some of the things we looked at earlier. So accept language, in this case, English, US English or just regular English. Accept encoding, we can accept gzip encoded data. And we can accept specific character sets. So ISO 8859-1, UTF-8, those are character sets that the browser defines as acceptable to retrieve. So we have that information there as well. We didn't talk about keep alive and connection, which are used to keep connections alive in case we're waiting on particular data. You can go read up on those a little bit yourself if you'd like. They're not really pertinent for us in this particular course. And then finally, in the optional header section, we have refer. In this case, it looks like we were referred by espn.go.com. So someone went to espn.go.com and part of the data they were reviewing required them to download /icon/in.gif GIF file, not a GIF file, a GIF file, of course. We got to get that right. And the refer is listed here for the benefit of the server, and it's probably going to log that data and use it for site statistics or troubleshooting later on. So that's the end of our request headers. We see that because here below we have a blank line, and then if there were a message body, we would see that. In this case, there isn't. You can see down here in packet bytes that the last thing we have is this CRLF as part of this blank line. So since it's a GET request, no additional content available here, and this is pretty much everything we have to work with. So this is just an example of just kind of walking through step by step of an HTTP request with a bunch of different optional header information. Now again, remember, that's going to vary pretty wildly based upon the HTTP client. Different clients are going to send different things, but this is what this particular client, this Firefox running on Linux, sent when it requested this data from the ESPN web server.